All right, so sunshine, weird, but it's coming through my window. So, the first thing I want to go through is labeling a right triangle. This triangle here, we know it's right because of the box, not because it's facing the right or anything like that. That box, a right triangle, has a angle measure of 90 degrees, and that box shows it. So that's a right triangle there. We generally name the angles with capital letters. So our right angle, the 90-degree angle, is the angle C, 90 degrees. That's the measure of the opening. And then other angle would be angle A and angle B. We also label our sides based off of the angle that it opens up to. So, for example, if you have an angle opening right here, call this angle C, the side it opens up to would be the side that connects the endpoints. So, like my pencil here. So, or we can think of it as the opposite of the angle. So, angle C, our 90-degree angle, opposite it would be side C, which would be labeled in lowercase letter. And that's the length of that side, the whole length of that side. Also, you could call that side segment AB. And then across from angle A, side A, across from angle B, side B. A key thing to also remember is always in a right triangle, you have two sides, we call those legs, and your longest side is the hypotenuse, and that is the one always across the 90. So in this case, side C or side A to B, that is going to be your hypotenuse. So I'm sure you've heard of this before because it is one of the most famous theorems in mathematics. That is the Pythagorean theorem. It's named for the ancient Greek mathematician Pythagoras. This theorem describes the relationship among the side lengths of a right triangle. So only a right triangle. It's the only type of triangles we're dealing with, right? Okay. With a 90-degree angle, it's a right triangle. Pythagorean theorem says in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So a squared plus b squared equals c squared. Most important part, that C, the one that's on the right-hand side of the equal side, has to be the hypotenuse, okay? So you will get it wrong if you don't put it in that hypotenuse, because when you do your algebra, it won't work out. So make sure first thing you do, find the hypotenuse, put it in that spot for the C.
It's Pythagorean theorem. It only works for right triangles. Remember that.
Thank you, Wrigley, for that study tip. Now let's go through some shortcuts. So sometimes you will find that you will often see triangles, right triangles, that have specific side lengths over and over again. A lot of times that's because teachers know that those work out. Those are side lengths that they know they create a right triangle, so we're going to use them. So if you get in a pattern of knowing like what you're looking for, you can actually do some of these Pythagorean theorem problems without actually doing the algebra and just knowing they are what are called Pythagorean triples. And so notes for here, it says a Pythagorean triple is a set of three positive integers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. So some common Pythagorean triples are 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. So what those mean is if you had a right triangle and maybe you knew that the sides of the legs were 3 and 4. If you memorize that there was a Pythagorean triple known as 3, 4, 5, you actually don't even need to do the math, a squared plus b squared, to find that c squared. And you can just know that it's 5. Also, multiples of those numbers will work. So 5, 12, 13, double those, 10, 24, 26. Those are going to be Pythagorean triples also. So there's a ton of Pythagorean triples that are out there. A lot of times math teachers just pull from them because that we know that they will work. So something to note and kind of keep your eye on. Example problems, if you haven't already clicked on them. And so this is 9.1 exercise number 1. Whoop. Zooming in. Nice thing about these note-taking templates, I even put the formulas in and some common Pythagorean triples there for you. Find the value of x. First thing we want to do when we do these problems is to write down the Pythagorean theorem. So that again was just a squared plus b squared equals c squared. Key thing is that the c must be the hypotenuse. So I always want you to first highlight or label the hypotenuse in any of these problems. And so in this case, hypotenuse across from the 90. So this is my hypotenuse. And abbreviation for hypotenuse, HYP, often used. The other two, the A and the B, they don't matter. They could be 4 or 6, like in reverse, because it's commuted property. The order doesn't matter. And so let's plug these in. So a squared plus b squared, again, they don't really matter the order. So I'm just going to go ahead and do 4 squared plus 6 squared, but the c does matter. That is our x, that's our hypotenuse, equals x squared. When we solve this, we just work piece by piece here. Do not plug this whole thing like this in your calculator in Desmos. Do as much as you can, just step by step. So 4 squared is 4 times 4, which is 16. 6 squared is 6 times 6, which is 36. X squared is still x squared. Let's add those together. 16 plus 36 is 52. So 52 is going to be equal to x squared. This is not our answer yet. We want to know the value of x. I believe we want them in decimal form too, so we are going to use our calculator. But so to find this, what we're looking for is what number times itself is 52. X squared, what number squared is 52. So to undo this, we're going to undo the doing. The opposite of squaring is the square root. So in order to get x by itself, we're going to square root both sides. That cancels that squared, and now we just have x equals whatever the square root of 52 is. So when we get our calculator out, I love when you guys use Desmos because we use the same thing. We're going to put in the square root of 52. So if we go to Desmos, www.desmos.com, make sure you click on Math Tools, and we are going to be using the scientific calculator in this class. And also make sure that word degree is in blue. Okay, very key. Do not toggle that. You can toggle, but toggle back. Degree must be shown there, or you will get any problems that we're going to be doing trig later wrong. So very key there. So we're doing the square root of 52. The Desmos is nice because order just square root. 52 left to right, just like you would reading. Sometimes in calculators, you hit 52, then the square root sign. Desmos is very to the point. It's exactly how it should be written. You type it in. So square root of 52 is 7.2. I'll just put that in. So 7.2 is our answer. Oops, don't want to do that. I want to drop. 7.2 is our x. So the question here was, is it a Pythagorean triple? 4, 6, 7.2. Did you see in the Pythagorean triples, where is that, any rounded numbers, any decimals? We did not. That's because they're only whole numbers. So 7.2 is actually a rounded number. 7.2, 111, 0251, 551 actually goes on and on, probably even further than that. So it's not a whole number. It is rounded. So it is not a true Pythagorean triple. It didn't work out perfectly. And so anytime you get a decimal, just know that it's not going to be that Pythagorean triple. So, or you can look at these. These are your Pythagorean triples. It's not one of those. So the answer is no. Next problem. Find the value of x. Okay, again, anytime you have a right triangle with two sides that you know, you can always use Pythagorean theorem. I did x. A squared plus b squared equals c squared. Hypotenuse is always across from the 90. That is our c. So we're going to put 15 in for the c. The other two don't matter. So I'm going to do x squared plus 9 squared equals 15 squared. Again, don't put this in your calculator like this. Do the work step by step on your own first. Okay, so x squared, 9 squared is 81. 15 squared is 225. Gosh, my writing, I'm missing some of these equals. 15 squared, 225. Put that in your calculator if you need to. We're going to solve this for x, so we want to subtract 81 from both sides. So then we get x squared equals, I'm going to have to put this one in my calculator, 225 minus 81. 144. And we want to solve this for x. Again, what number times itself is 144? So we're looking for the square root of that, 144. X equals square root of 144. Put that in your calculator. It's 12. And some of you guys might have known that. Okay, something key to note here. I got 12 as my answer for x. Okay, this is a good time to sit and look at your problem and think, okay, does that make sense? Did I do this correctly? Which side is supposed to be the longest? The longest side is supposed to be the hypotenuse, 15. Okay, this still is. What if I would have gotten 17 or something like that for my x? Well, I should have known, okay, I did something wrong because the longest side is the 15. So if I got something longer than 15, then something's wrong. So make sure you're double checking your work to make sure, go back, see if you need to ask for help or do it again. So we have a triple here. If we do it in least to greatest, 9, 12, 15. Was that a Pythagorean triple? Well, it was a whole number that ended up. So 5, 12, 13. Ooh. 9, 12, 13 is what we're looking for. I think that's a multiple. Yeah, 3, 4, 5. Yeah, 9, 12, 15. We scroll up to those. 9, 12, 15 is right here. So that was a Pythagorean triple. It was a multiple of 3, 4, 5. So from the get-go, you probably could have even noticed that here that we've got, this really is like 9 divided by 3 is 3, 15 divided by 3 is 3, or 5, sorry, 3, 5, and then this one would be 4. So you can kind of get to those. Also, I always say step out your calculator work like this, but if you get after you do a few of these, if you're getting quicker on them, then you can take some shortcuts in your calculator, but no shortcuts until you get the concept down of what you're doing and you're getting them correct. Okay. Next up, we're going to talk about the converse, and just a reminder that the converse is a theorem in reverse. It's not the shoe, but maybe it'll help you remember it. Reverse it up. The converse of the Pythagorean theorem, if the square of the lengths of the longest side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is going to be a right triangle, okay? So far we've learned, okay, if it's a right triangle, then we can use Pythagorean theorem, a squared plus b squared equals c squared. The converse is take that and put it in reverse. Say, what if we don't know the angle measure? What if we don't know if it's a right triangle or not? Well, if we know all three sides, we can test it. We can say, okay, if the Pythagorean theorem works, if a squared plus b squared does indeed equal c squared, then it is going to be a right triangle. So that's the converse.
It's Pythagorean theorem. It only works for right triangles. Remember that.
All right, so if Pythagorean theorem works, it's a right triangle. What happens if it doesn't work? What if a squared plus b squared is not equal to c squared? Then is it a wrong triangle? No, the two other options are obtuse or acute. We actually have some formulas here. Take a screenshot because this one even I'm always like, which one is it? So when you do Pythagorean theorem, if a squared plus b squared equals c squared, right triangle, easy. If a squared plus b squared is less than c squared, so the amount on the left is less than the amount on the right, it's going to be an obtuse triangle. If a squared plus b squared is greater than, so that number is bigger, the alligator eats a bigger number than c squared, then it's an acute triangle. And again, c is always going to be that longest side, so because we're assuming we're trying to check it to see if that Pythagorean theorem works. So we're checking to see if c really is indeed that hypotenuse. So make sure you're putting the c in the equation as the longest side when you're checking these. Problems here, we are going to use that information about the converse of the Pythagorean theorem and then determining what kind of triangle it is. So the first one here just says tell whether it's a right triangle. The triangle is or is not a right triangle here. So this one I'm not going to post that little handy dandy formula, but I'm just going to use Pythagorean theorem, because if it's a right triangle, then Pythagorean theorem will work. So I'm going to start by writing out Pythagorean theorem. A squared plus b squared equals c squared. Again, that c has to be the hypotenuse. Which one do we assume would be the hypotenuse in this case? Well, if it's a right triangle, then 97 needs to be our hypotenuse, which is our c. The other two don't matter, so I'm just going to do 65 squared plus 72 squared and see if that equals 97 squared. To do these, I would just break it apart and check the left side to set it equal, see if it equals the right side. So I'm going to do all at once. I'm going to let you do a little bit of a shortcut here. 65 squared plus 72 squared. So 65 squared, that's how you do it there in your calculator, plus 72 squared, 9409. So this side is 9409. Is that equal to this side, 97 squared? And we'll go ahead and put that in. And hit equal, so then you have the other one above to compare as well. 97 squared, 9409 sure is the same. That one's nice and fun. So yes, those two are equal. There you go. Yes, they are. Tell whether it's right. Since they're equal, the triangle is a right triangle. Okay, what about if they're not? I'm assuming maybe these won't be. We'll see. So I am going to post in here that little handy dandy cheat sheet, because it's like, wait a second, I really don't remember what those were. Okay, so Pythagorean inequality. Whoops, sorry, didn't mean to move that. The side lengths are 10, 11, and 14. So let's see, are they going to equal each other, or is it going to be an obtuse or acute? So again, we'll just do that. A squared plus b squared. Does it equal c squared? It's like kind of like question mark. Does it equal c squared? Put them in. C is going to be always the longest one, so the 14. So make sure that gets put in for the c. So 10 squared plus 11 squared equals 14 squared. Let's check these out. 10 squared plus 11 squared. Let's put those in our calculator. $221. Is that going to equal 14 squared? They don't equal. That's 196. What do we do now? Okay, alligator's mouth's going to eat the bigger number. Alligator's mouth eats that number. So the alligator's mouth eats the a squared plus b squared. Which one would that one be? Alligator's mouth eats a squared plus b squared. The answer to this one is it's going to be a cute little triangle. Okay. And honors, try this one on your own first. Pause the recording. Give it a go, and then come check back here. So do that now. Pause that. In this case, I did put 6 root 43 in my calculator, and I confirmed it is the longest side. So that is my c. So a squared plus b squared doesn't equal c squared. 24 squared plus 30 squared, does it equal 6 root 43? This is the key thing right here. Put that whole thing in parentheses and square the whole thing. Okay, so 24 squared plus 30 squared, this is where a calculator comes in really nice. 24 squared plus, I forgot what it was, 30 squared. That's 1476. Is that going to equal 6 root 43 squared? So if you want to do this one in your head, just a reminder that squared goes to both things. So you square the 6, 36. You square the square root of 43, that cancels out. So this is really 36 times 43. Okay, or you could just put in your calculator 6 root 43. But how you do that, you need to put the parentheses. So 6 square root 43. Make sure you click to the right so it ends parenthesis the whole thing, not just the root 43, and then hit squared. 1548. Okay, make sure it's typed in like that in your calculator. 1548. Okay, and look at that. The alligator's mouth is going to equal or eat the right side. So alligator's mouth eats the c squared. That would be like, whoops, didn't mean to do that. That would be like this one here, which was an obtuse triangle. Okay, go ahead and do your assignment. Let me know if you have any questions. Happy to help. So as a reminder from Wrigley, if you have a right triangle and no two sides, you can use that Pythagorean theorem to find the third side. So again, recall Pythagorean theorem, a squared plus b squared equals c squared. But what if you don't know the length of two sides? What do? What we use is trigonometry. Trigonometry is a branch of mathematics that deals with the relationships between the sides and angles of triangles. A trigonometric ratio is the ratio of the lengths of the two sides of a right triangle. Okay, so all right triangles with a given acute angle, so say you have two right triangles and they both have the same acute angle, are going to be similar by the angle-angle similarity theorem. You have the 90-degree angles that are the same, and you have the other angle that's congruent, and thus the angles are similar. Because they're similar, we can set up ratios, proportions, and trigonometric ratios. So when we're doing trig ratios, a lot of times we don't know the measure of an angle in the triangle. And so I wanted to make sure you guys knew what that little symbol meant. So the acute angle in the triangle often is going to be called the angle theta. Theta is a Greek letter, and it looks like a circle, sort of, or an O, or maybe a zero with a squiggly line in the middle of it. And so all that is, when you see that, it's just an unknown. So it's kind of like our x when we're trying to find a side length and we don't know it. We usually call it x or a. But for angles, when we don't know it, we are going to call it theta. I'm also going to refer to binoculars because that's where our eyes are always going to go, is to that angle theta. So when I say get your binoculars out and look, we're always going to put them where our angle theta is. So there are three trig ratios. You may have heard of them before. There's sine, cosine, and tangent. And in this lesson, we are going to start by just going over the tangent ratio. Okay. So the tangent ratio is the ratio of the opposite side to the adjacent side in a right triangle. And you might be wondering, okay, what does that mean? What is the opposite side? What is the adjacent side? And so it really is based off of that angle theta that you either know or are trying to find. And so we're going to go through next here how you're going to label your triangle in order to find those opposite and adjacent sides, because our tangent ratio is the ratio of the opposite side to the adjacent side again. Steps to labeling the sides of a right triangle. We're going to label the sides either opposite, adjacent, or hypotenuse. Okay. First step is you're going to label your hypotenuse. You always label your hypotenuse first. This is always the side that is across from the right angle. It is also always the longest side. So find your right angle and directly across from it, shoot an arrow, hit it. That's your hypotenuse, your longest side. Step 2, place your binoculars. These go at the angle theta. Sometimes you know theta and there will be an angle measure there. Sometimes you won't and it'll say theta. So, but the angle you know or the angle you're trying to find, that's where your binoculars go. Step 3 is to label the opposite side. This is the side opposite of the angle theta. Looking out your binoculars, which side is opposite? Step 4 then, only side left is the adjacent side. You're going to label this. This is the side next to the angle theta that you know. This side is one of the legs of the angle. All right, remember to use those steps every time you label your triangle. Your triangle will always have side lengths that are hypotenuse, the longest side across the right angle, the opposite side, the side that is across from the angle theta that we know, and the adjacent side, the side next to the angle theta. So we know how to label our sides, and now we can use the tangent ratio. Again, tangent theta is equal to the ratio of our opposite side divided by our adjacent side. So whatever the length of the opposite side is, divided by the length of the adjacent side. And we're going to use this to solve some problems to find out some missing side lengths. All right, here are the steps we are going to use to find an unknown side of a right triangle using trig. And don't worry, we can pull these with us when we do some problems, and as we get to doing some problems, you'll see why we do each step and how it leads us to finding the solution to the problem. So step 1 is always, again, label the sides of the triangle. Hypotenuse first, then opposite, then adjacent. So you got to label those. Step 2 is you're going to determine which trig ratio to use. This one's easy today because every problem is going to be using tangent. So we're not going to worry about sine or cosine, just tangent. Step 3, create an equation, write it down. And step 4, plug it in and solve for the unknown. Here's the key though, you guys. You cannot do this without a calculator. Tangent is a ratio that has been set up, and you can use like a really big Excel spreadsheet to find the ratio and all that, but your calculator is really, you actually can't do this one in your head. So you have to use a calculator to use those trig ratios. And so we are going to, in class, use Desmos. If you want, you can use a handheld calculator, but it is easier if you just use the same calculator that I'm showing with Desmos, because order does matter differently on different calculators. And so I want you to take a second and go to www.desmos.com, and I'm going to show you here on the next slide what it looks like and which calculator in Desmos we are going to be using. Desmos.com, and so this is what the main page looks like. So make sure you're all here. You don't need to log in to an account, sign up, or anything like that. We're just going to use the calculator. And so the easiest way I've found to get to the calculator, we're not going to use our graphing calculator. So math tools, we're going to use our scientific calculator for geometry. So click that one, scientific calculator. And you'll see right here, you can see those trig functions, sine, cosine, and tangent. It is actually super important, this toggle right here, that it is toggled so that it is on degree. So make sure the DEG degree is showing blue here. Otherwise, you're actually going to get every problem wrong. Same thing, it's like a mode in your calculator. If you use like a TI-83 or something like that, make sure the mode is degrees. And if you are noticing that you're getting every problem wrong, it could be because your calculator is in the wrong mode. So it is important your calculator is in that their degrees. So make sure the blue is hovering. The degree part is blue. Okay. And so this is our Desmos that we're going to use. And you can actually see here, you can even, type things in here if you ever need to. This other key here, function key, when we do inverse trig functions, you can see sine, cosine, tangent are also here. So are these what are called inverse trig functions. So we're going to use those there as well. So fiddle around with Desmos for a bit, and because we're going to be using it in some problems to come. Into our little note-taking template here, and we're going to do a few problems together. Again, remember these steps, they are listed out here on your note-taking template. Going through, labeling the hypotenuse first, then the opposite, then the adjacent, and then the steps. So we can always resort back to those as we're doing some of these problems. The first one here, we're actually not solving for any variable. We're just doing like the beginning work of setting up the ratios. So the first question says, find the tangent of J. What that means is find the tangent of angle J, okay? Angle J is our theta. And so tangent of angle J, just a reminder, tangent ratio, tangent of whatever our angle theta, J in this case, is equal to the ratio of what the length of the opposite side is to the length of the adjacent side. Okay, so the first step when we do these, just remembering here, label the sides of the triangle, hypotenuse, opposite, and then adjacent. So labeling our triangle, hypotenuse is always going to be the longest side. It's the side that is across from the right angle. And so we're going to label that one first. So click right here, across from that right angle, right there is our 40-degree side, the longest one. That is our hypotenuse, just abbreviation for hypotenuse there. Then again, to label the opposite and adjacent, it is based off of where your binoculars are, where the theta is. So in this case, it wanted us to find the tangent of angle J. So that's our theta. Okay, so at angle J right here, that's where we're going to put our eyeballs. That's where our theta, that's where our binoculars are. So according to that angle, we can then label our opposite side. So you would shoot an arrow, hit the opposite side. So our opposite side, the side that's the length 24. And then last but not least, we have the side that shares, if you were to make an angle here, it has the legs, not the hypotenuse, but the other side it's next to. That's our adjacent side. So then filling this out, the tangent of angle J is going to equal the opposite side, which is 40, over, hopefully you guys caught me on that one, not 40, opposite side. Which one's the opposite side? The opposite side's here. The red one, it's the blue one. Opposite side is this one. So the opposite side was 24 over the adjacent side, which was 32. Okay, we're going to go ahead and then it says, write each fraction in simplest form as a decimal rounded to 4 decimal places. So simplest form, let's reduce that. What numbers divide evenly into those? 8 divides both into 24 and 32. So 8 goes into 24, 8, 16, 24 3 times. And 8 goes into 32, 8, 16, 24 times. So 3/4 is our lowest decimal. We're going to put that into our calculator. So I'm going to open up Desmos here. I'm just going to do 3 divided by 4, and I get 0.75. So that is our answer for that one, tangent of angle J. Okay, now we want to know, though, the tangent of angle K. And we actually cannot just use those. We can't say, okay, it's opposite or adjacent. That's the tangent of angle J. We have to relabel our triangle. So I'm going to go ahead and delete how I labeled before, because now our eyeballs aren't going to be at J. Our eyeballs are actually going to be at K. So let's delete some stuff here. I'm not going to delete where I labeled my hypotenuse, because remember, hypotenuse is always the side that is across from the 90-degree angle. It's always the longest side, and so the hypotenuse is never going to change. That one doesn't change, but the opposite and the adjacent do change based off of what angle we're looking at. So angle K, let's go ahead and get our binoculars out, and this time they're going to go at angle K. So angle K right here, binoculars go here. And we'll label our opposite side. So if we shoot our arrow that flip-flops this time, our opposite side is over here. And our adjacent side would then be here. So tangent of angle K is equal to opposite over adjacent. Opposite was 32, adjacent was 24. So that will reduce to 8, 16, 24 over 3 this time. Put that into our calculator. .333 repeating. That means repeating. Okay, so this one's just setting up the ratio. Next, we are going to actually solve for some variables. So notice here, number 4 and number 5, we have an angle, we have a side length, and we're trying to find another side. Same thing here. We know an angle, we know a side, and we know a side here, and we're trying to find another side. Something to note, maybe to think about too, we could actually fill in these unknown angles because a reminder, the sum of the angles of a triangle is always 180. So we know this is 90, this is 56, so this would be, and this is 90, this is 61. But we're not asked for that in this case. Later on, we will be asked to solve a triangle and we will need that work, but for now, we're just going to use those tangent ratios. So again, I'm going to write this out here that the tangent of our angle theta is the ratio of the opposite side over the adjacent. Okay, and our first step, let's label our triangle. So that was step 1, label your triangle. Label the hypotenuse first. Across from the 90 is my hypotenuse. Okay, opposite and adjacent, again, it's based off of the angle you know. In this case, like the previous one, we were trying to, locate K and J. But in this case, theta, where your binoculars go, they go at the angle that you know. So we know this angle here is 61 degrees. That's when we're going to put in for theta. And so that is where our binoculars go. And so shoot an arrow straight across. I'm going to delete that because I wrote over the problem, but that one is going to be my opposite side. And then this side over here is my adjacent side. Okay, so let's plug in what we know into this formula. Tangent of theta, theta is 61 degrees, equals the opposite side length, 22, over the adjacent side, x. So notice what we have here. We have one unknown x. That is because tan 61, I'm actually going to show you this here. It is a number in your calculator. Okay, so hit clear. And if you hit tan 61, it's 1.804. Okay, we could put that number in right now. Okay, we could go back to our problem and be like, okay, let's put in 1.804 here, solve it for x. It does work out a little bit better, especially with rounding, if you wait till the end and then plug it in. So that's what I'm going to do, just because it keeps your answer a little bit more correct, because putting rounded numbers always gets you a little bit off more. So how do we solve this? We're like, wait, what? A couple ways to think about this. You could think about it as tangent 61 over 1, cross multiply, solve. It's the same thing as doing, we're going to want to get rid of that x down here. That x is what's kind of throwing us off. So we're going to multiply both sides by that x. Okay. And what you do to one side, you must do to the other. Okay. Then we have x times the tangent of 61 degrees equals, when you multiply these, they cancel because x over x is just 1, 22. Okay, again, we still want to just solve this for x. It's our goal here. So eyes go on that x. We want to get that x by itself. Right now it's x times tan 61. Opposite of multiplying is dividing. So we are going to divide both sides by that tan 61. And again, remember, tan 61 is just a number. So divide both sides by tan 61. Daughter talking downstairs, sorry. Those crossed out because it's really just the number 1. So our answer, x, is going to equal 22 divided by tan 61. And that's just why it's a little easier just to put it in now at the end, because you can do it all at once. 22 divided by tan 61. And our answer, 12 point, well, how many decimals did we want? Nearest tenth. So 12.19. These are going to be approximate answers. Already forgot it. 12.19. So our answer, x, is approximately 12.19. Okay, and you double check to make sure that made sense. Looking at it, it is a shorter side than this one. This one's 22. So if you would have got an answer that was like 750, you're like, it seems really off. Especially works out if you know your hypotenuse, because you know that that's going to be your longest leg. So your answer here would have had to be shorter than whatever your hypotenuse was. So be aware when you're doing these problems and solving them, like what the answer should look like, and to make sure to double check that you're doing it correctly. All right, let's do one more just to solidify that we know this. I'm going to go a little bit quicker on this one. Feel free to pause this recording and try it on your own, and then come back and check to make sure you did it correctly. And I did have this link for Desmos here. It's like my ad, I guess, but I'm going to delete it so I have more space. All right, so first step is to label my triangle. Okay, so my hypotenuse is going to be always across from the 90. So this is my hypotenuse. Okay, angle I know is right here. That's where my eyeballs go. Opposite is this side then, and adjacent is this side. Tangent theta equals opposite over adjacent. Plug in what we know. Tangent theta, theta is 56 degrees, equals the length of the opposite side. That one we don't know, that's the x, over 13, the adjacent side. This one's a little bit easier. Notice the difference here. The previous one, the x was on the bottom, so we had to go through a few more steps to solve it. This one, the x is on the top. It's actually a little bit easier because to solve it, we just multiply both sides by 13. Or again, put it over 1, cross multiply, solve, gets you to the same answer. Multiply both sides by 13. We can just put that one, because now all of a sudden we have x only on this side. That's our answer. 13 times tan 56. We go over here to Desmos. 13 times tan 56, 19.27. And so 19.27 approximately is equal to our x. Again, double check that looks about right. Sure does. I mean, the shortest side is 13. It's going to be a little bit longer. We don't know the hypotenuse yet. We could actually, I want to go even further. This side, like we just said, was 19.27. You now have two sides. You're trying to find your third. It's a right triangle. You can use Pythagorean theorem to find that third side if you want. Then you know every angle and every side of the triangle. Fun stuff. All right, reach out. This stuff is tricky, so be sure to reach out for help if you need it. We have learned that the tangent ratio is the ratio of the opposite side to the adjacent side in a right triangle. Okay, so we've learned that ratio. Today, we're going to talk about the other two. We are going to talk about sine and cosine, and we're going to go over when and why we pick sine, cosine, or tangent. Before we go into that, quick reminder, because we still need to be able to label our triangle correctly, how to label the sides of a right triangle. Remember, we have opposite, adjacent, and hypotenuse. First thing, label the hypotenuse. It is always the side across from the right angle. It's also the longest. Step 2, place your binoculars or your eyeballs at the angle theta that you know or are trying to find. Then we're going to label the opposite side. This is the side opposite of the angle theta. Look through those binoculars. And then your adjacent side is the side next to the angle theta. This is the one that's last there and has legs of the angle. So now that we have our sides labeled with our angle theta that we know, and again, remember they change depending on where that angle theta is, we can talk about our three trig ratios. The tangent ratio, it's the ratio of the opposite side to the adjacent side. Okay, the sine ratio, it's the ratio of the opposite side to the hypotenuse. And the cosine ratio is going to be the ratio of the adjacent side to the hypotenuse. And guess what? We have a fun way to remember that, so don't worry about trying to memorize it. SOHCAHTOA. SOHCAHTOA is an easy way to remember trig ratios. The word SOHCAHTOA helps remember the definitions of sine, cosine, and tangent. Here is how it works. Okay, the first one, the acronym part, SO. The verbal description of that is sine is opposite over hypotenuse. Sine of angle A is opposite over hypotenuse. Sine OH. So cosine, adjacent over hypotenuse. So cosine of angle A, adjacent over hypotenuse, C-A-H, ka. TOA, tangent is opposite over adjacent. So TOA, tangent, opposite over adjacent. So sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite over adjacent. If you remember SOHCAHTOA, you can remember which ones go with which. Also, you can use your notes. SOHCAHTOA. And I do want to go through the steps one more time for finding an unknown side of a right triangle using trig. Same steps as we listed when solving using tangent. This time in step 2, remember when we were doing tangent, I said all these problems are going to be tangent. So disregard so and ka, but this time we have to choose. So that's a key one. Step 2, determining which trig ratio to use. So step 1, label the side. Step 2, determine which trig ratio to use. Step 3, create your equation, write it down. Step 4, use a calculator because you have to, desmos.com, and solve. And I actually put in here, if unknown is in the numerator, so in the top, the x is in the top, there's an example of how you solve that. You just multiply by the denominator and then solve. If unknown is in the denominator, if the x is in the denominator, a little bit harder, you have to multiply both sides by x and then solve. So those are just some examples similar to ones we've done before or that we are going to do that might come up. So save that in your notes. It's in there just as your help. So we use these steps to solve some problems. Next. It does go through our trigonometry, tangent, sine, and cosine. Just a note here, tangent, ratio of opposite over adjacent. The abbreviation for tangent is just tan. So that's why tangent looks like tan here. Sine, the abbreviation is sin. Takes the E off. Cut a little short, I guess. And then cosine, the abbreviation is cos. So if you ever see those, they mean the same thing. It's just the abbreviation. Same thing here. Hyp stands for hypotenuse. Op stands for opposite. And ADJ, it stands for adjacent. So I want to go through those really quick. Your steps also are always here if you need them. And we're going to go through a few problems together. Make this a little bit bigger. All right, so it looks like we just have 2 quick problems. So wants you to find the sine of D, sine of F, cosine of D, cosine of F. Write each answer as a fraction and as a decimal rounded to 4 places. Fun. Okay, so let's start with D. So let's just solve the problems that we're dealing with angle D, because again, how you label your triangle is based off of the angle we're looking at. So we're going to do these ones first with the D. So this is our angle D. This is where my eyeballs are going to go. Okay, so this is a right triangle. Our 90-degree angle is right here. Across from our 90-degree angle, our longest side, again, that is our hypotenuse. Let's just keep that in blue, I guess, here. Hypotenuse. Opposites across from our eyeballs, shoot an arrow, hit. This was going to be our opposite side. And then process of elimination or sharing an angle with that side is our adjacent. All right, so I'm going to go ahead. I think I'm just going to copy paste from up here to make it a little bit easier. I'm just going to copy this and bring it down here so we can have it handy. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Oh, no, that is not what I wanted. Got it all grouped, huh? No, paste it. There we go. Bloop. All right, that will help us out. SOHCAHTOA. Okay. Sine of angle D. Sine is the ratio of the opposite over the hypotenuse. So sine of angle D is the ratio of opposite, which is 7, over hypotenuse, which is 25. That actually cannot be reduced. 7 over 25. Pop that into Desmos. 0.28. Cosine of angle D, we're still looking at angle D. Cosine is the ratio of adjacent over hypotenuse. So the adjacent is 24. I'm going to change, oops, didn't want that. 24 over hypotenuse, 25. Again, can't reduce that. 24 divided by 25. 0.96. Oops, I even put that in the wrong spot, didn't I? 24 over 25 and 0.96. I'm going to change colors so that I don't look like I'm like overlapping here. Okay, that's for angle D. Okay, next we want to do angle F. So I'm going to go ahead and I'm going to keep my hypotenuse the same here because that one doesn't change, but my eyeballs are going to change to a different location. We're going to change them to angle F. And so our opposite and our adjacent are going to flip-flop. So where's angle F? Right here. That's where my eyeballs are going to go. So my opposite is now here, and my adjacent is the 7. So sine of angle F, sine opposite over hypotenuse. So opposite is 24, hypotenuse is 25. Is going to be that one, and then we know that one's 0.96. Okay, you can kind of see a pattern here. Cosine of angle F, cosine is adjacent over hypotenuse. So adjacent is 7, hypotenuse is 25, 7 over 25. That pattern, 0.28. What do you notice that happens? What do you compare about the two of those when you flip-flop them like that? That's all you had to do on that one. We weren't doing any solving. This one we are. So we're going to go through our steps up here. So label, determine, all those things. And okay, so find the values of u and t using sine and cosine. Deep breaths. We can do this, right? All right. First step, label the sides of your triangle. So, okay, let's find u first. Let's not even worry about t. Let's just worry about u. Okay, so because there's a couple ways we could actually do this. We're going to put our eyeballs here at the angle we know, 65 degrees. Eyeballs here. So label our triangle. Crossing the 90 is our hypotenuse. So this is my hypotenuse, the 8. Opposite the angle we know is my opposite side. And then my adjacent side is the u here. All right. So let's find angle u. So what do we know? So when we're trying to determine, so that's our, what step was that? Step 2. Determine which trig ratio. How you determine which trig ratio you use is you figure out what do we know and what are we trying to find. Okay, so in this case, we know the hypotenuse. I'm going to do a highlight. We know the hypotenuse. What are we trying to find? Well, we're working on u in this case. To find u, we want to find the adjacent. So that's going to tell us what trig ratio we're going to use. We're going to use the trig ratio that deals with adjacent and hypotenuse. So which trig ratio, I thought I just have that right there, deals with adjacent and hypotenuse. Adjacent, hypotenuse, cosine. Okay. I also think sometimes we don't care about the opposite. So which one has to do with opposite? These ones. So we don't care about those. We want adjacent and hypotenuse. So not cosine. So that's your step then, is to write the equation. So cosine theta equals adjacent over hypotenuse. Okay. Cosine theta. What is our theta? Theta is the angle we know, 65. Equals adjacent, which is u, over hypotenuse, which is 8. Okay, we're going to solve this. Remember, if the number's on the bottom, it's a little bit easier. To get rid of that 8, we multiply both sides by that 8. So our answer is just 8 times the cosine of 65. Go back to our Desmos. 8 times cosine 65. 3.38. It's you see how the squiggly lines, those mean approximate. So u is approximately 3.38. 3.38. Okay, from here is a few ways we could go. We could actually just do Pythagorean theorem. 3.38 squared plus t squared equals 8 squared. Solve it for t. That is taking a rounded number and, going through and rounding it even more. So not going to give you the most accurate answer, but it works. But let's just, because I want to, keep working on these types of problems where we are, solving using trig, I want to go through it using trig. So next we are going to find t, side t. So I'm just gonna pretend we don't even know you. I don't know you yet. I'm not gonna have it there. All right, so to find t, this time I'm gonna highlight what we wanna find. We wanna find the t, which is opposite. And again, we're going to highlight what we know. And even if we did put in that we knew adjacent was 3.38, that's not one we would say we technically know. We found it, and it's a rounded answer, and so we're not really going to use it. We're going to use this one that we know here. This is that 8. It's a whole number. It's not rounded. It's going to, be a lot easier. So opposite and hypotenuse, that is sine. Color change right there. That's cool. And so we are going to set up our equation for sine. So sine theta equals opposite over hypotenuse. Okay, so plug that in. Sine of theta, theta's the angle we know. It's still 65, nothing changed there. Equals opposite, which was t. That's a t. It's like a weird t. Divided by hypotenuse, 8. Look at that. This one's another nice easy one. You multiply both sides by 8. 8 times the sine of 65. Just delete this here. How nice that was. 8 times sine 65. Let's see if that worked the same. 8 times sine 65. Yeah. 7.25. That's again a t. It's kind of like weird F, right? I don't know why I write my t's like that. 7.25. My answer there. Just for a challenge, one more thing you could do, just a reminder that the sum of the angles of a triangle is 180. So we could have done 90 minus 65 is 25. We could have labeled the fact that this angle here is 25 degrees, and we actually could have used that as my eyeballs, and then this would have been opposite, this would have been hypotenuse, this would have been adjacent, and I'll bet you get the same answers. So maybe give it a try if you want. And again, this stuff's tricky, so be sure and reach out if you're stuck or needing help or want to go through some more problems together. Okay, you guys, we did it. We are at the final lesson of our trigonometry unit. In this lesson, we are going to use a big word. The word is solve. We are the Solve It team. We are going to solve right triangles. So to solve a right triangle means to find all unknown side lengths and angle measures. You can solve a right triangle when you know either of the following. Okay, so if you know just two side lengths, for example, here. Obviously, we already know one angle. Yes, I know, but it's called a right triangle. So that's a given that we know one angle measure. We know that it has a 90-degree angle. So if you know the 90-degree angle, you know it's a right triangle, and you know two side lengths, you can solve the right triangle. And we've actually done some problems where you know one side length and the measure of one acute angle, like this one here. We know the hypotenuse is 8, and we have an angle measure of 65, including the 90-degree right angle. So you can also solve those. So these are a little harder. A little more what we're going to work on today are the ones where we don't have an angle measure. How are we going to solve them? Okay, let's do a quick recap of what we know and we might need to use in order to solve these triangles, okay? Again, this is all in your note-taking template, so make sure you click the link above, click Use Template for a new design, make a copy, print it if you need to, save it, whatever you wish. First thing is that the sum of the angles of a triangle is always 360. Okay, so that's one step in solving. If you have a right triangle, you already know one angle. Say you're given another angle is 22 degrees. We can solve for the third angle right away because we know the sum of the angles is 360 degrees. Did I say 22 degrees? So 90 minus 22, 68 degrees would be your third angle. All right. I hope I did that right. Okay. Next, if you have a right triangle and you know two side lengths, you can use that Pythagorean theorem. Okay. Right triangle, two side lengths. In order to find the third side, you can use a squared plus b squared equals c squared. One step closer to solving that right triangle. And then recall that if you know a side and an angle of a right triangle, you can use trigonometry to find the other side. SOHCAHTOA, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. But what if you don't know any angles? All these have to do with like knowing at least one angle other than the 90 degree, unless you're just finding one side. If you don't know any angles and you only have a side or another side, how do you find the angles? Okay, we're going to go through that next. Let's dissect this a little bit. Get our dissection tools. Let's take a look at a new type of trigonometry problem. Interestingly, these problems can't be solved with sine, cosine, or tangent. What? I thought this was trig. In the triangle below, what is the measure of angle L? Okay, we've got angle L. I don't know. Let's go through like what we would do normally when we'd set up trig. Okay, relative to angle L, we know the length of the opposite and the adjacent side. Okay, 35 is that opposite, 65 is the adjacent, opposite over adjacent. That was SOHCAHTOA. So we're going to use tangent. Okay, so we can write that out. Tangent of our angle L is going to equal opposite over adjacent. Tangent of angle L equals 35 over 65. But what do we do from here? Usually we hit like tangent a number and put it in our calculator and got something out. But this is tangent angle L. How do we do that? How do we put that in our calculator? We are stuck. What we need is a new mathematical tool to solve problems like these. Our old friends sine, cosine, and tangent aren't up to the task. They take angles and give side ratios, but we need functions to take side ratios and give angles. We need the opposite. We need inverse trig functions. Okay, you guys, Pearl's here for a misconception alert. She wants you to make sure you know that sine to the negative 1 of x is not the same thing as 1 over sine x. Some of you guys remember in algebra that when you did to the negative 1 power, it flipped the fraction. Not the case here, okay? The negative 1 is not an exponent. Instead, it simply just means inverse function. Sometimes you will actually see inverse sine, inverse cosine, inverse tangent written as inverse. You will see them written to the negative 1 power. You also sometimes will see arc sine, arc cos, and arc tan. They all mean the same thing. Why do they do that to you? I don't know. Just keep it as one thing. But so you know, they all mean the same thing. And straight from your Big Ideas textbook, an inverse trigonometric function undoes what the original trigonometric function does, as in the case with any other function and its inverse. So inverse trig ratios, the inverse tangent undoes tangent A, inverse sine undoes sine, and then inverse cosine undoes cosine. The key thing to note here is it's just a button in your calculator, okay? So we are going to use Desmos, so make sure you have your www.desmos out and follow along as you do it, so you make sure you're clicking the right buttons on your calculator when we do some problems. Into your note-taking template. This is kind of key this time because I did add in here a cheat sheet for solving right triangles, and we'll go through that in a minute here. But this one's kind of a key one because it encompasses everything we've learned so far. And so if you really just have notes on one lesson, this is the one. So we learned about inverse trig functions. I want to make sure we go through some together using Desmos to make sure you're understanding what buttons you're hitting in Desmos. So we're going to scroll down to right here at the bottom of page A, so 9.6a. So inverse trig functions, again, we're going to use www.desmos.com. So make sure you do have Desmos open. I'm going to go to the main page here, www.desmos.com. Make sure you guys, again, are just hitting that math tools and going to scientific calculator. I believe you can just click here too. Yeah, you can. Okay. So you'll see here in your calculator, again, first off, I've been through this many times, so make sure you guys are paying attention to this part, that the word DEG is in blue, degrees. We are using degrees. We are not using radians, okay? Radians is a measurement that deals with the radius of a circle, and so we're using degrees. We're using out of 360 degrees. So we are in degrees, so make sure that is clicked. Toggle, you'll get them all wrong. Make sure it's on degrees. You'll notice here we have sine, cosine, and tangent. Where are those inverse ones? Where are they? How are they written in Desmos? If you click that function key right here, you'll see more options show up. We have sine, cosine, and tangent. We also have sine inverse, cos inverse, and tangent inverse. We have mean, standard deviation, all these other things that we actually will use in next semester. But for now, we're just going to use these 6 keys for our problems. So make sure you do have that open and ready to go. And you'll find these to be pretty easy once you know the steps, okay? So it says let angle A and B and C be acute angles, use technology. Oh my gosh, what does that even mean? Anytime you see the word use technology, that means use your calculator, okay? Technology is big ideas, way to say use your calculator, use Desmos. Desmos to approximate the measure of angle A, angle B, and angle C. Okay. What I say here is, so right now you have tangent of angle A equals 0.75. Okay. How do we solve that? What do we put in our calculator? Okay. So I'm going to go through kind of the longhand work of this. And then we'll just do the shortcut after that. So what we want to do is we want to solve this for angle A. We want to know what the measure of angle A is. Okay. So really you want to get rid of that word tangent. Get rid of that tan. So then we have A all by itself. To get rid of the word tan, we do the inverse operation. To take the inverse of tangent, we take tan inverse. Tan inverse. That cancels it out, okay? Tan inverse times tan cancels the word out. Bloop. What you do to one side, you must do to the other. So we're going to take the tan inverse of that 0.75, and that's going to give us angle A. Okay, so to get rid of it, take the inverse. It undoes it. So in our calculator, we're going to do tan inverse of 0.75. Tan inverse, go back to main, 0.75. What we're looking for is an angle measure, so it should be a number that looks kind of like an angle measure. So it's below 90. It should be under 90, an acute angle. So we're at 36.8 degrees. Let's round that to 36.9 degrees. It doesn't tell you. So 36.9 degrees is what I'm going to go with for that one. Okay. As we get more and more on these, you'll see that all we're doing is flipping these two places and putting that -1 key in. So we're finding the sine inverse of 0.87, and that's going to give us angle B. Okay. Sine inverse 0.87. Make sure you change it. We're doing sine inverse in this case. 0.87. Calculator number 60.5 degrees. It's the sine inverse of that. If you're getting all different numbers when you put it in, it is probably because your calculator is in radians. So please make sure, if you're not using Desmos, use Desmos. Make sure the degree is in blue. If you're using a calculator, make sure your calculator doesn't say radians in the corner somewhere. Change the mode to degrees. Okay, this one I'm going to flip-flop them again because we want the cos inverse to undo it. So cos inverse of 0.15 is going to give us the measure of angle C, cos inverse of 0.15. (81.4 degrees). Okay, don't take shortcuts. There is no shortcut. 81.4 degrees. Okay, that's just putting in your calculator just to make sure you're all there. We are still going to need to set some equations up and then use this. So that's what we have going on next. Actually, not quite next. It's one after that. Okay. 9.6 example, let G be an acute angle such that the tangent is 0.43. You see that word again, use technology. Anytime you see that, it just means use desmos, or your calculator to approximate the value. Okay, so again, we've got tangent of angle G equals 0.43. I'm going to go through the longhand version of this, but really you're just undoing it. So we're going to get rid of that tan word. So we're going to do tan inverse. That cancels that out. Angle G equals what you do to one side, the tan inverse of the other side, 0.43. Put that in your calculator, tan inverse of 0.43. Hit that function key, tan inverse 0.43. I think that was the number, right? Yes. Hit enter, 23.3 degrees. Nearest 10th of degree, yep, 20. Oh my gosh, I already forgot it. 23.3. Okay, if you get something wrong too because of your rounding or your decimals amount, reach out. I'm happy to give you points back for something like that. All right, so that's that. Just putting your calculator part. Let's do a whole problem. We are going to solve this problem. Oh, we're going to take everything we know. Before I do that, I'm going to go through our little cheat sheet here of what we know for solving a right triangle again. Okay, step 1. Label the sides of the triangle, hypotenuse, opposite, and adjacent, according to those binoculars. Okay, do you guys remember this? It hasn't been that long, has it? Step 2, use Pythagorean theorem. If you know two sides, I won't put you through the torture of playing Wrigley saying, you can only use Pythagorean theorem for right triangles. Use it if you can. You might not be able to, but use it if you can. Step 3, determine which trig ratio to solve for. Are you going to use sine, cosine, or tangent? SOHCAHTOA. Step 4, create your equation, write it down. Step 5, plug it in, use that calculator, and solve. And here are some finding unknown sides and angles hints. If the unknown is the numerator, so the x is on the top, you just multiply both sides by that denominator. If unknown is in the denominator, if the x is in the bottom, you're going to have to multiply by that x and then divide. And if you are trying to find an angle, I always say this one as a reminder, if you're ever stuck and you're trying to find an angle, remember to use inverse. Okay, angle, inverse, angle, inverse, angle, inverse, angle. Use the inverse. All right, we're going to try problems. All sorts of different ways to solve these. So I would actually say pause this recording, try it on your own first. Maybe you're doing it a different way than I am doing, but you will likely get to the same conclusion. Okay. First thing I'm going to do is I am going to find side DE because we have a right triangle with two sides and we can use Pythagorean theorem. So that's C. So I'm going to use A squared plus B squared equals C squared. I'm going to plug those in, 20 squared plus 21 squared, and I'm going to get my C squared. 20 squared plus 21 squared. Um, 841. Solve that. I'm going to take the square root of both sides. Square root of 841. 29. It's a whole number. It was a Pythagorean triple. So we get 29 for our C. We're almost there, aren't we? We've got one side, C. Bloop. Let's delete that and put it in. 29. Okay, we're almost done, aren't we? Now we have two more angles we have to find. DE 29. Okay, let's find angle D. This is my theta. That's where I'm going to put my binoculars because that's what I want to find. Remember, we used to be like, what's the angle we know or the angle we want to find? I used to say that too, and you're probably like, why is she saying that? This is why. All right, first step, remember, is to label your sides. So always label your hypotenuse first. Hypotenuse is across from the 90, so this is my hypotenuse. According to my eyeballs is my opposite, so this is my opposite, 21. And then process of elimination, the one next to is my adjacent, 20. This one's kind of nice here since we already solved and we found the hypotenuse of 29 and we know all three sides. We can actually use sine, cosine, or tangent, any of them. I though am going to maybe we didn't use Pythagorean theorem first and we actually only knew the 21 and the 20 and we didn't know this side was 29. So that way we only could use opposite and adjacent. So toa, that's tangent. So we're going to use tangent in this case. You'll see actually when you're trying to find the angle, it's fewer algebra steps. So you might learn to like these. So we write it out just as we would before. Tangent of theta is opposite over adjacent. Again, we're using tangent. You could have used in this case, like I said, all three, but in case you only knew the 21 and the 20, tangent. We're going to plug in what we know. Tangent theta, that angle theta, it had a D there. Just put my eyeballs over it. So it's really angle D. Tangent of angle D, we don't know what that is. We can't put anything in there. Equals opposite. We know the opposite is 21. We know the adjacent is 20. Okay, remember in our notes, remember angle inverse. We're trying to find the angle measure. We're going to use inverse. So make that swap. Inverse tan cancels it out. Angle D is going to equal the tan inverse of that fraction, 21 over 20, okay? That's probably the hardest part is figuring out that swap, but you really just, anytime you're trying to undo it, just think it's like division, but it's not, it's inverse. So you put in your calculator with the inverse symbol, tan inverse 21 over 20. Hit that function key, tan inverse, make sure you make it hitting that one, not just the regular tan. 21 divided by 20. 46.4 degrees. Okay, we got angle D now, 46.4 degrees. Okay, we could use all sorts of things. We could now use trigonometry, SOHCAHTOA. The easiest thing though, don't forget, remember the sum of the angles? If we know this is 46.4 degrees, all three angles must add up to 360. So 360 minus 90 is 90. If we do 90 minus that 46.4 degrees, that's going to give us our final angle, 90 minus 46.4. 43.6 degrees is our final angle, 43.6 degrees. And that one was angle E. These are all approximate answers, rounded. Also, again, I know I went through this kind of fast. You can always rewind, go through it again. I highly recommend you trying it on your own, catching maybe where you're off. If you got the same answers and you did it differently, totally fine. There are many ways to use this. Like I said, had I not solved for Pythagorean theorem first, had I did, now I can use sine, cosine, or tangent. I could find angle E first. So many different ways. And again, please reach out for help, especially before you do your checkpoint assignment, so we can make sure this stuff is solidified knowledge in your brain. Thanks for watching. Have a great day.